Algebraic long division. First we're going to look at a normal long division like you would have done it at primary school. So we're going to look at 23 divided into 7,176. First we consider here how many 23s go into 7, doesn't work. How many 23s go into 71? We see that there's 3 23s that go into 71, so we write a little 3 on above. 3 times 23 is only 69 though. Write the 69 underneath. And we're going to consider 71 take away the 69. And that's going to leave us with a 2. It's not really a 2 because it's in the hundreds column. So we're going to pull down the number in the tens column, so we're going to pull down the 7. And now we're considering how many 23s there is in that 27. Here we've got 1. Again, one lot of 23 is just 23. And we'll do the 27 take away the 23, gives us the 4. It's not really a 4 though, because it's in the tens column. It's really a 40. So we'll pull down the 6 and we'll have a look at how many 23s there is in 46. This is nice, there's 2. 2 times 23 is 46. So take them away, you've got no remainder there. So 7176 divided by 23 is exactly 312. Algebraically, it's a very similar process. So we'll have a look at how many x plus 2's go into x cubed plus 5x squared plus 4x minus 4. And it's the x that's the important bit here. X is the unknown. So we'll consider how many x's go into x cubed. Clearly, x squared x's go into x cubed. So we'll have a look at what x squared times by x plus 2 is. We get x cubed plus 2x squared. Same as we did before, we're going to take them away. X cubed take away x cubed is nothing, that's the whole point. 5x squared take away 2x squared is 3x squared. Same as we did before, we're going to bring down that next number. That next number is a plus 4x. So we look at how many x's go into the 3x squared. Well, that's just 3x, so it's positive 3x. 3x times by the x plus 2 is going to give us 3x squared plus 6x. Same as we did before, we're going to take them away. 3x squared minus 3x squared goes away, that's the whole point. 4x take away 6x is minus 2x. Like we did before, bring down the minus 4. How many x plus 2's go into minus 2x minus 4? Well, it's minus 2. So minus 2 times by x plus 2 gives us minus 2x minus 4. They're exactly the same, so there's no remainder there, so that's a perfect factorisation. Another example here, we'll look at how many x plus 1's go into 2x cubed plus 3x squared minus 1. Note there's no x term here. What I've done is I've left a gap because we're still going to need the space when we do the proper long division. So I've left a gap where there should be an x. Same as we did before, we consider how many x's go into 2x cubed. Well, it's 2x squared. Now we'll consider what 2x squared times the bracket is. We get 2x cubed plus 2x squared. Same as before, take them away. 3x squared minus 2x squared is just 1x squared. Pull down the other term. There is no x term, so we could write plus 0x if you wanted, but I've left it blank. How many x's go into x squared? Well, there's just x. X times the bracket gives me x squared plus x. Remember here I'm going to do a take away, so I've got no x's, take away plus x gives me minus x. Pull down the minus 1. How many x's go into minus x? Well, it's minus 1. Minus 1 times the bracket gives me minus x minus 1. Minus x minus 1 minus x minus 1 is nothing. There's no remainder here. Thank you.